One of the important fights in the coronavirus battle is happening on a DNA level. Today we hear from Major Jeffrey Kugelman, Branch Chief of the Genomics at U.S. Army Medical Research Institute for Infectious Diseases in Fort Detrick, Maryland. So what is this overall? A lab area?
Yeah, this is our genomics lab.
If there's something mysterious going on somewhere in the country, it may come here.
Yes.
What else have you done related to this lab regarding coronavirus?
So one of the big things we've done this year is we've created a method, optimized a method for massive pooling of samples. So we have a way using the instruments here, you'll see, that can put 1,000, multiple thousands of samples in a single run, and within a day have a result on whether they have COVID or not. We've also multiplexed that with flu so that the same sample can then be tested at the same time for flu and for COVID. And the big deal is that it increases the throughput. So instead of doing this with a few hundred, we're doing thousands at a time.
And what is this lab called?
This laboratory is our primary PCR core laboratory.
Kathleen Gibson's division fills in more pieces of the genetic puzzle. So you can test for coronavirus in samples here?
Yes, we can.
So mostly on this location you do military troop samples?
Yes.
And, okay, what are these?
So this is a setup where we're getting ready to run some samples this afternoon. So each subsequent step in the process will extract and purify the DNA. When it gets to the end state, then we'll be able to load it into the instrument that will actually tell us how much DNA is in there.
It's here at USAMRIID.
Major Kugelman says some lessons have been learned from the Ebola epidemic in West Africa, where he did some of the critical work.
So this is a Mysq instrument. This is probably the most ubiquitous of the Illumina instruments. I took one of these with me to Liberia when we were supporting the Ebola outbreak in 2015-16 timeframe.
And in really simple terms, what does this allow you to do?
So this will provide 20 to 40 million small fragment reads, about 300 base pairs long. So for coronavirus, because the virus moves a little slower, it allows us to tell what's circulating in our region. For something that moves very fast, like Ebola virus, we're actually able to tell which individual infected which individual.
The Ebola outbreak in West Africa became an emergency in the U.S. when there were no travel restrictions and a man carried the virus to Dallas. Public pressure prompted an emergency program to funnel passengers from Ebola-stricken nations to one of 5 U.S. airports for screening.
In work we did in the West African outbreak, we were able to provide the first evidence that Ebola was being sexually transmitted, and that was causing those flare-ups at the end of the outbreak. And so they were releasing men that were testing negative by blood back home, and as soon as they became sexually active, at that point, we'd have another flare-up of Ebola.
And this helped you figure that out?
This helped us figure that out.
Kugelman's team has also been studying animals to find out exactly what happens if someone gets the flu and COVID at the same time. So far, researchers say the results seem to confirm co-infection makes the illness more severe.